Hey friends, welcome to the YouTube channel all about electronics. So in this question, this Zener diode is used as a voltage regulator. So this circuit provides a 5 volt across this 1 kilo ohm load. And in this question, just assume that the Zener diode has a constant reverse breakdown voltage of 5 volt when the current through the Zener diode is between Iz minimum and the Iz maximum, where this Iz minimum is the minimum required current for the Zener diode to operate it in the breakdown region. So in this circuit, the nominal input voltage is equal to 6 volt, but it may vary between plus minus 5%. So here, we have been asked to find the value of this series resistor R and the minimum required power dissipation of this Zener diode. So in the given circuit, as far as the current through the Zener diode is between Iz minimum and the Iz maximum, then it will operate in the breakdown region. That means in that case, the voltage across the Zener diode will remain 5 volt. Or in other words, the output voltage will remain 5 volt. So here, let's say the current through this 1 kilo ohm load is equal to IL. So in this case, this IL will be equal to 5 volt divided by 1 kilo ohm, that is equal to 5 milliampere. And whenever the Zener diode is operating in the breakdown region, then some current will also flow through this Zener diode. So let's say this current is equal to Iz. And let's say the current which is supplied by the source voltage is equal to Is. So we can say that this Is is equal to Iz plus IL. Now whenever the Zener diode is operating in the breakdown region, then the output voltage will remain 5 volt. That means this IL will remain fixed. So this Is will be minimum when the Iz is equal to minimum. Or in other words, the supplied current will be minimum when the current through the Zener diode is equal to minimum. So we can say that this Is minimum is equal to Iz minimum plus IL. Similarly, the supplied current will be maximum when the current through the Zener diode is also maximum. That means Is maximum will be equal to Iz maximum plus IL. Apart from that, here we have been given that the nominal input voltage is equal to 6 volt and it may vary by plus minus 5%. That means in minimum will be equal to 6 volt minus zero point 0.3 volt, that is equal to 5.7 volt. Similarly, this V in maximum will be equal to 6 volt plus zero point 0.3 volt, that is equal to 6.3 volt. So due to the 5% variation, the input voltage may vary between 5.7 volt and the 6.3 volt. Now here, the value of R should be selected such that when the input is minimum, at that time also, the current which is supplied by the source voltage is at least equal to Is minimum. So we can say that this Is minimum is equal to this V in minimum minus Vz, that is the voltage at this node, divided by R. Now here, this Iz minimum is equal to 2 milliampere while this IL is equal to 5 milliampere. That means Is minimum is equal to 2 milliampere plus 5 milliampere, that is equal to 7 milliampere. So from this we can say that this 7 milliampere is equal to V in minimum, that is 5.7 volt minus Vz, that is 5 volt divided by R. Or we can say that this R is equal to 0.7 volt divided by 7 milliampere, that is equal to 100 ohm. That means whenever this input is minimum at that time, to supply a current of at least Is minimum, the required value of R should be equal to 100 ohm. Now with this value of R, let us find the value of the Is maximum. So this Is maximum can be given as V in max minus Vz divided by R, because with the given value of R, this Is will be maximum when the input voltage is maximum. That means Is maximum will be equal to 6.3 volt minus Vz, that is 5 volt divided by 100 ohm, that is equal to 13 milliampere. Now here this load current IL is fixed, that is equal to 5 milliampere. That means out of the 13 milliampere, the 5 milliampere will flow through the load. That means the remaining current has to flow through this Zener diode, and that will be the maximum current which is flowing through the Zener diode. So from this we can say that for the given circuit, this Iz maximum is equal to this Is maximum minus IL, that is equal to 13 milliampere minus 5 milliampere, that is equal to 8 milliampere. That means the Iz max is equal to 8 milliampere, and this current will flow through the Zener diode when the input voltage is maximum. And in this case, since the Zener diode is still operating in the breakdown region, so the output across the Zener diode will be equal to 5 volt. So in this case, if we see the power dissipation across this Zener diode, then this Pz will be equal to this Iz max times Vz, that is equal to 8 milliampere times 5 volt, that is equal to 40 milliwatt. That means with the value of R is equal to 100 ohm, when the input voltage is maximum, then the power dissipation across the Zener diode is equal to 40 milliwatt. And to withstand this power, the minimum power dissipation of the Zener diode should be at least equal to 40 milliwatt. So from this we can say that the required value of R is equal to 100 ohm, and the minimum required power dissipation rating of the Zener diode should be equal to 40 milliwatt. And therefore, for the given question, this is the correct answer.